There we go. Audio should be working now. This is just going to be a short stream. I quickly ended the stream, I guess it was yesterday, because I had to run to an event. But in the meantime, figured out what I needed to do for this robot name thing. So I still haven't verified yet, but I believe it's still okay to, for the entire data structure for the robot to just be its name, because there's no other information about the robot. So even if we pass it to the robot's name is just the robot. So that's why. That's the definition of robot name. It's a function that takes a robot and just returns back robot. And reset name, instead of even using the robot itself, just creates a new one, essentially. Just generates a new name. So I was trying this thing with take 3, and I was running into some issues, and there's several issues that I think there was. The first one was I was using the repeat incorrectly. So repeat will just take whatever you give it. No, so let's see what. So let's say we do do repeat page 3 and try executing that, and I'll just keep repeating it indefinitely. If you give it a number, let's say we're going to repeat 2 3 times. So there it is. So what happens is if you actually do rand nth, so if we were to do rand nth, sure, let's do rand int, sure. It's actually going to call rand int once and then repeat that. So it's actually not going to give you 2 things, but repeatedly will. So repeatedly will take the function and call it as many times as you want it to. So repeatedly here is giving us 2 different letters. So that's exactly what we want here. So that's the first issue that we had. So got that fixed here. So repeatedly 2 is what we want there. So same thing here. We want to do, I guess this would be repeatedly 3, and then we don't need the take 3 anymore. So what we're going to do is we're going to press Control Alt comma. That spit that bit out there, and then we can just get rid of this. There we go. Now the next bit is these 2. So this bit right here, this line here, will return back a collection of 2 letters, and then the other bit will give me a collection of 3 numbers. But string is expecting, or str is a function that's expecting its arguments. First of all, it's expecting them to not be, like if you're giving it a list of things, they all need to be arguments there. And the second thing is, right now there's 2 lists that have to be essentially concatenated together, 2 collections. So I guess the first thing is, how do we concatenate those 2 things together? Let's figure out. Clojure concat lists. Turns a lazy sequence. I don't know if we want a lazy sequence. There's also that into. Okay. What is the correct way to just concat the 2 lists though? Union. Programming idioms. That one looks promising. Let's see. Primitive sequences, creating sequence in, sequence out, using a sequence, construct collection, check force, transducers, collections. Here we go. Lists. Vectors. Seems like a concat should work. Alright, we'll do that. So what we want to do here is we're going to do concat and slurp in both of those. So what I pressed there was Control Alt period. And now instead of doing string like that, we want to do apply string. I think that's what we want. There was a way to auto format this. Was it Control? No, that's not what we want. Okay. So let's see what calling robot does now. Hey, look at that. That's exactly what I want. Cool. Alright, so to evaluate that, I was pressing Alt Enter, and Alt Enter will evaluate that line there. So every time we press Alt Enter, it's giving a pretty unique robot name there. So I think that should be enough. Do a line test to see if it passes all the tests. And test failed. 2 of them failed. Okay. So it's saying that its new name was the same as its original name. New name's different each time. Robot name expected not its new name. Robot name reset name. Let's take a look at that again. So it's saying that new name different is failing. So it's creating a new robot. It's grabbing its original name. It's grabbing do robot reset name with the robot and getting the name for a robot. Okay. So here's the issue with this. So resetting the name of the robot and then passing that thing in interesting. So here what's happening is it's creating a robot. It's grabbing its original name. Then it's resetting the name of that robot, which in our case is going to generate a random new one. And then grabbing its name. But instead of passing in so it's passing in a robot. Okay. So that's not going to work. So essentially what's happening is like it needs to remember here where we're saying reset name, it doesn't work to just generate a new one. Because it needs to hold on to some metadata about that robot. Reset name. Okay. So how do we want to do this? Well, I suppose we could gotta have some sort of data structure now. So this has got to return back. Clojure has these maps or something, I think. Sorted maps. Two different maps types are provided. Hashed and sorted hash maps require keys that correctly support hash code and equals. require keys to implement a comparable or instances of comparator. So hash map is how we do it. I thought there was a way to just like use a curly bracket. Data structures. Strings, characters, keywords, symbols, collections. Maps. Struct maps. Array maps. Sets. Interesting. I thought there was this like curly bracket notation for maps. Guess not. Okay. Well, let's take a look at how to use maps then. So here we have a map as a collection. Okay. Def demo keys hash map Z1 B2 A3. Demo keys. Okay. Creation sorted maps. Returns a value mapped to a key not found or nil if key is not present. Get hmap key. Get demo keys B. Interesting. I thought there was this way of like kind of just calling it as a function almost. So let me try this out. So we'll say hash map name robot. Sure, we'll do that. Okay, that's nice. And we'll say okay. Now here's the other issue, right? The way this test is written, a robot has to be mutated, right? Reset name for a robot and then calling its name again. It has to actually mutate it. Okay. So we have to do mutable data structures. I know there are some mutable data structures. I'm pretty sure there are in Clojure, but they certainly dissuade you from using them, and I would certainly prefer not to use them. But let's think about if there's a way to do this without, right? So in the test here, it's saying I create a robot, we grab its original name out, we then reset its name and then grab its name again with this reference to a robot. So again, without having assigned the reset of the name to something, a robot has to have mutated. Yeah, I don't see any way around it. Okay. All of them are saying immutable data structures. Well, I need a mutable data structure. All right, let's see. misspelled Clojure there, but we'll see if it understands. Yeah. Okay, you can create a mutable map structure in Clojure using a def record macro. Def record person ID named def person person1 John. Here we've created a person called person with 2 fields ID and a name. We also create an instance of this record called person. You can associate the name of the person using the soak function like this. This will create a new instance of the person record with the same ID but with a different name. Let's see if that's true. Okay. Def updated person, so person name. Well, okay, updated person, association person. Let's just try associate person name chain. Okay, and now at this point, we're going to say person name. Nope, doesn't like that. I think there's a way to just like, what is the name of the person or something? Yeah, there it is, okay. So this is not mutating, it doesn't look like. Okay, so that's not correct. Def person, person1 John, name, ID. Okay. The record is immutable. How can I actually mutate the record? Here we have created an atom called person, which contains an instance of the person record. We can update the name of the person using the swap function like this. Swap person associated name. This will update the name of the person in place. Let's see if that's true. Well, I guess I missed that bit. Def. No, I didn't quite. Okay. Swap person association name chain. That didn't work. Execution error. Class cast exception. Okay. Swap person. Well, let's try this again. Let's reevaluate that. Evaluate that. Nope, still not liking it. Can update the name of the person. Let's see if that's a thing in Clojure. Well, actually, let's do. Usually, I can get quite a bit of information from learn X and Y. Let's do Clojure. Mute. Use do to make dealing with mutable classes more tolerable. Do to dot set. Let's see. know what? I don't think I ever defined Adam or a person there. Oh, I did. Deaf person right there. So I've got a person right there, and here I'm trying to swap it. Swap Adam name function. Maybe this needs to be a function there. Slurp that in. How does this work? Adam name is the name of the atom whose value needs to be reset. Function is a function which needs to generate a new value of the atom. The atom with the new value will be set based on the function provided. Okay. How did I well, let's just say that this function just returns the function that returns 2. That's all it does. Okay, it doesn't like that. Oops. So I want spit that out. Okay, let's see. See an example of this. Okay. So we'll say we'll try out this example here. Def my atom, atom 1. Swap my atom increment. So I want to see what my atom evaluates to. Oh, maybe it's just because it doesn't get evaluated like that. Oops. Atom, okay. I think we're getting there. Okay, so I think what we're going to do is we need robots to be encapsulated in a atom. So what I'm going to do is I'm going to create a function to generate the name. Generate name. Excellent. Okay, and then we'll grab all that stuff out of there. And what we're going to do is we're going to create a new. We're going to create an atom. We're going to say def my atom, and then we're just going to return that atom. When I did that, does it actually? The def doesn't return the atom itself. So if we say def robot hash map name generate name, and then make sure we return back the robot. Syntax error, compiling. At 9:30. Hash map name generate name. Oh, and def my atom. Atom is actually how you create it, right? So can I put whatever I want inside there? Can I just say atom? The atom will contain a hash map. Can the atom just contain the name? Perhaps. I guess so. Still doesn't like that. What's going on? Oh, I think it's up here. There we go. Still doesn't like it. It's okay with that. Okay, here we are. Alright, let's see what robot spits out now. Haha, okay, it's an atom with that name in there. It's spitting out a new one each time. Excellent, okay. So just calling robot will create a new one with a new atom. So in the case of robot name, we just return back, I guess it's fine to just return back the thing itself, but it probably has to, how do I get the value of an atom? Let's see. Hey, got someone watching. Watching this makes my brain hurt. Yeah, it's making my brain hurt too. It's kind of weird exercise because Clojure likes to use immutable data structures and makes it really easy to do that. But this exercise kind of requires mutability. So let's look up Clojure get atom value. I had to check to see if something is in an atom. That makes it sound like the atom is almost transparent in a sense then. And can access its state with deref. Ref. Let's go back. At mem. Interesting. At mem. Let's see if that's what we wanted it to do. So we'll say def r robot, and then we'll say robot name r. Doesn't like that. Okay. What if I just did it without that? Nope, didn't like that either. Calling that robot name R. We called robot name on R, and it says it's a function. Why is it a function? Let's see. Def n robot. Well, you know what I'm gonna do? I'm gonna plow forward. We're gonna take that robot and we're gonna do a swap on the robot. swap atom, and then the function that we want to call on it. So we want to generate name. Why is that yelling at us? Not sure why that's yelling at us there. Happy now? Let's run the test, see what's going on with that. Interesting. Same. Is it the same too? It is, okay. Error in robot name. Line test only, robot name. Def test robot name. So robot name and fail in new name different. Error in new name matches. Fail in new names different. Okay, you know what? I think it's okay. So there's 2 failures and 2 errors now. So basically, the robot name guy is not working correctly because we can't just return back the atom. So the question is, how do we get the value out of this atom? So we've got this, we've got that. Try dereferring it. That did work there. So we should be able to just deref robot. Because robot is an atom, right? What am I doing wrong here? Okay. Robot is, in fact, creating R is saying that it's a function here. Why is R a function? Why is it not a robot or an atom? What happens if I call it? Okay, so maybe this shouldn't be called like that. So if I do that now, and then call R here, why is it still def R robot? Okay. Still says it's a function. Interesting. Where does Clojure apply? What are AOF field or use? Not sure if I understand the question correctly, but Clojure is and the reason why I'm doing this, sorry, just kind of rolling with this with no intros, going through the exercises on Exercism to learn a few languages, and the month of June is the summer of S expressions. Clojure is a Lisp along with Common Lisp, Emacs, Racket, Scheme, a few others. I've done quite a few of the Clojure exercises already. I'm about a third of the way in. 29.9%. However, this is my first time running into anything requiring mutability. Clojure is a Lisp that runs on the JVM, and it's probably one of the most popular Lisps in production today. Not entirely sure which companies are using it, but it's pretty well used at the moment. The guy who made it is named Rich Hickey, and his talks are brilliant. They're a lot of fun to watch on YouTube. So if you haven't checked those out, those are definitely worth watching. Alright, so I think it's interesting that this seems to... Let me now just try calling robot itself on its own. Okay, so if I just call robot on its own now, it's not even returning the atom anymore, right? So I think I still want to be wrapping that in this atom bit. And now if I try calling robot, it's now returning the atom. Okay. Now when I call robot, I say def r robot. Oh, you know what? That's what's going on here. I didn't actually call. There we are. Okay, now I'm going to call R, get the atom. Good. And then when we then call robot name on R, we should get the actual string. Okay, so I think this is correct. And then when we call reset name on, okay, if I keep calling robot name on R, it shouldn't change. But then when I say reset name on R, okay, we get an arity exception here. Now, it may be because, so here, this one worked with swap, just passing increment directly as a function there. So we had def myatom atom1, then we did swap myatom increment, and then we called the reference of myatom, and it was 2. So here, generate name is supposed to just be able to return back. Oh no, okay. Generate name is expecting an argument essentially, right? Because we could give it a fake argument. That should do it. But I don't really like it. It should work. If that works, well, we'll refactor and make it so that it works better. Okay, still not working. Okay. So swap is expecting automatically swaps the value of atom to be apply f current value of atom args. Note that f may be called multiple times, and that should be free of side effects. Return the value that was swapped in. So it's going to pass the current value of the atom to generate name. So generate name is expected to be a function that takes at least one argument. So let's see if we can understand the error here. A lot of this is Java related errors. Let's go with the stack here. Class cast exception. Class Clojure lang atom cannot be casted class java.lang char sequence. Clojure lang.atom is an unnamed module of loader app. Okay, so let's just make sure everything's working correctly again. Robot should actually return back a... Oh, okay, so that's already an issue. Arity exception at robot name robot. Oh, okay, because robot now... Robot's expecting at least one argument? What? No, that's not right. Arity exception to robot name. Arity exception? Okay, let's refactor this again. We don't want this. So this needs to be a function. There was a way to do a quick anonymous function. There we go. That looks better. Okay. So let's do robot there. Gives us an atom. Def r robot gives us r. R is now an atom. Good. If we grab its name, its now JQ863. I should keep being able to get its name. It should be the same. I should be able to reset its name, and now it's a new one. And now if I grab the value of R now, it should be that. Excellent. So that all looks good. Let's see if it passes tests. Interesting. So it's still failing the tests. It's weird because like it works as expected, I think. New names different each time. Expected not its new name. Do robot name, reset name, a robot name, a robot. Actual, not equal. When we grab robot name of a robot, it's returning back an atom. So robot name is returning back an atom. It doesn't seem to be an atom when I'm calling it here. What am I doing differently here than what they were doing there? Actually, you know what I'm going to do? I'm going to actually take one of their tests. This one was new names different each time. Okay. Go all the way down here. Stick that in there. And we're going to say is not its original name is equal to his new name. And let's see, missing another one of those. Still missing another one. Okay. So it is true now. It's saying, okay, I got a robot here. Its original name is here. Its new name is we're resetting it, and then we're getting its name, and we're saying make sure that they're different. And yeah, it's saying that's true. So I don't really know what's going on. I'm not sure if maybe this comment block's messing with it. Wasn't able to compile it correctly, perhaps. If that was all it was, it'd be a play. Hey! Okay, so it's passing now. Cool. Well, now we learned how to do mutability in Clojure. They have these things called atoms. Still pretty straightforward, I guess. Pretty happy with the implementation here. This is a little interesting here. I think I can simplify the syntax slightly. I think what I can do is I can perhaps put that in front there, and no, maybe not. I'm gonna go undo that. We're just gonna leave it. Run the test again. Okay, I'm fine with that. We'll submit that exercise. I think I didn't submit the exercise for, what was it? Difference of squares. Well, maybe I did. I just didn't complete it in here. Okay, go back here. Got robot name. Mark is complete. And return to exercise. We'll go back to the other exercise that we finished, which was difference of squares, and we'll mark that as complete too. Cool. How far are we on this now? Third of the way through. Nice. Okay. Well, I think that's it for today. Thanks, Not Ziegers, for stopping in, asking a couple questions. Pretty new to the streaming thing, just kind of doing it for fun. And made some progress today, so I'm pretty happy with that. And we're kind of call it a day. See you later.